we now need to look at how the size of a parachute is going to, or the surface area of that parachute, is going to affect the terminal velocity. So we're going to take 4 parachutes. They're going to have different surface areas. They're each going to have 3 jumps done on them, and then we're going to record the terminal velocity each time upon landing. So what are we changing? We're choosing 4 different parachutes with 4 different surface areas or sizes of parachute. And what are we measuring? We're measuring the terminal velocity. So first we need to link those two in a suitable hypothesis. A hypothesis is always a statement. So we could say something like, the greater the surface area, the lower the terminal velocity. Or the greater the surface area, the greater the terminal velocity. Doesn't matter whether it's right or wrong, as long as it links the independent and dependent variables using a statement. What is the independent variable? The independent variable is always what I've chosen to change. So in this case, it is the surface area of the parachutes. Give 2 variables that would need to be controlled in this investigation. There are lots of different ones, but the height of the jump, the mass of the person, the surface area of the person, the mass of the surface and surface area of the person with their clothes, the weather conditions would need to be the same. It would need to be in the same place on Earth, not on the top of a mountain and then near the ocean. Any of those would have been acceptable. And why did Zara jump 3 times instead of just once? To have more repeats, what do repeats do? They ensure precision, and hopefully in the process, with precision, that you're going to get some accuracy as well. But the word that we also like to see, which embodies both precision and accuracy, is that by doing a number of repeats, we land up with a fair test. We have taken a good look at what has changed and what has stayed the same. Taking a look at these results over here, we've got our surface area of the, and we have 1 surface area, double the surface area, triple the surface area, quadruple the surface area. We're looking at the velocities, and we see that we land up with something that looks a bit like a hyperbola. So it looks like it might be an inverse proportionality, because if you think about it, y is equal to k over x for a hyperbola, which means that you have got an inverse proportionality. As the one goes up, the other one goes down in proportion. What we do then is we decide to check and look at what happens if I change that. And they haven't just changed 1 over v. They've gone for 1 over v squared, which means that when I land up with a straight line over here, my v squared is like the y on a straight line graph, and the surface area is like the x. So the proportionality is going to be surface area is directly proportional to 1 over v squared. So what do the results indicate about the relationship between surface area and terminal velocity? It is going to be that surface area is equal to 1 over v squared. The surface area is inversely proportional to the square of the terminal velocity.